Hello and welcome to the conversion factors video. In this class we're going to be using conversion factors to solve most of our math problems. Conversion factors are also sometimes known as dimensional analysis or unit cancellation. You might have learned about this in another class under a different name. You may already be familiar with it. But it's going to be very important that we use these ratios to cancel units. And in order to receive full credit on exams, and lab reports, you will need to show your work in this way. So here we have a very simple example for practice. The problem indicates a person weighs 164 pounds and asks us what is the mass of this person in kilograms. So the problem's asking us to convert 164 pounds into kilograms. And so in order to do this, we need to know the relationship between these quantities. And we can look this up in the textbook for homework assignments and whatnot, or for exams, you'll be given these quantities, a table of these quantities. And so from this equality, we can make two different conversion factors. That's these ratios shown here to the right. And how do we know which one we want to use? Well, I'll show you guys a simple trick. So we are given in the problem that the person has a weight of 164 pounds. We want to pick the conversion factor that puts pounds in the bottom, because we want to cancel out the pounds right here. So whatever unit we want to get rid of goes in the bottom. So we're going to select this conversion factor. And so now our pounds down in the denominator are going to cancel out these pounds over here. And if we punch this into our calculator, it'd be 164 times 1 divided by 2.20 would give us 74.5 kilograms. And so the 1 kilogram here is going to be exact, but these other values are known to 3 sig figs. And this is in two different measurement systems, so this is not exact right here, this 2.20, that's measured. So 3 sig figs, and therefore our answer can have 3 sig figs. And so there is our final answer. Looking at another simple example right here, if a rattlesnake is 2.44 meters long, so the length is 2.44 meters, how many centimeters long is the snake? And so it's asking us to convert from centimeters into meters, so we'd have to look up that 1 meter equals 100 centimeters. This is the same measurement system, so it's exact. We can make two different conversion factors out of it. So we start out with our 2.44 meters, and we're going to pick the conversion factor on the left now, because that puts the meters in the denominator, and that's the unit we're trying to cancel. So these meters cancel out those meters. And if we put this in our calculator, 2.44 times 100 divided by 1 gives us 244 centimeters. And so this conversion is exact because it's the same measurement system, but this starting quantity is only known to 3 sig figs, and therefore our answer can only be known to 3 sig figs. So go ahead and pause the video and try questions numbers 1 and 2 on the conversion factors activity, and these are going to be these one-step sort of conversions like we showed. And if you need to look up the equalities, you can use the table of equalities and equations that you can find in Canvas, or you can use the textbook. Hello, and welcome back. One of the things you'll be asked to do is string together multiple conversion factors to solve a problem. And we have some examples shown right here. So a doctor prescribes a dosage of 0.150 micrograms of Synthroid. And if a tablet contains 75 micrograms of Synthroid, how many tablets are required to provide the prescribed medication? So we need to know our relationship between milligrams and micrograms. If we look that up, 1 milligram equals 1,000 micrograms, and we can make two different conversion factors from that. And then we also need to know how many micrograms in our tablet. 1 tablet equals 75 micrograms, and this is given in our problem. And so again, what we're trying to find is how many tablets are going to correspond to 0.150 milligrams of Synthroid. So we're trying to figure out the relationship between those things. We're going to start with our given quantity here, our 0.150 milligrams. So we begin with that right here, and we have to figure out which one of these conversions to use for milligrams to micrograms. We want to use the one on the left, because that's going to put the milligrams in the denominator, so we can cancel out these milligrams with these milligrams, and that's going to convert us to micrograms, which gets us one step closer to our answer, but we're not quite there yet. And then from there, we need to know our relationship between tablets and micrograms, and that's given the problem. We're going to pick our conversion factor on the right, because that puts micrograms in the denominator, and so our micrograms here can cancel with our micrograms here, and this will spit us out an answer in tablets. And so to punch this into our calculator, we would use 0.150 milligrams times 1,000 times 1 divided by 1 divided by 75. And if we crunch all our numbers, we end up with 2 tablets as our final answer. Or I believe since we're restricted to 2 sig figs, that should actually be 2.0 tablets. So moving on and taking a look at another example where we have to use multiple conversion factors. If your pace on a treadmill is 65 meters per minute, so there's our pace, that's an important piece of information. How many minutes will it take you to walk a distance of 0.75 kilometers? And so we want to figure out minutes. So how many minutes is what we're looking for, and we're starting with our 7.5 kilometers. So first we need to know our ratio between kilometers and meters, because we can see they're both mentioned in the problem. And 1 kilometer equals 10 to the third meters, or 1,000 meters. And our pace on the treadmill means that our relationship is that there's 65 meters for every 1 minute. This is given in the problem. So we're going to start out with our 7.5 kilometers. And we need to figure out which one of these conversions to use right here. And we're going to pick the one that puts the kilometers on the bottom, so they'll cancel out the kilometers in our starting number. So bam, and bam, those cancel out. And then we need another conversion, because we're not asked for meters, we're asked for minutes. So we need to know the relationship between meters and minutes. Well, that's where this conversion factor comes into play. We're going to pick the one on the right, so the meters in the denominator will cancel it with the meters in the previous conversion factor. Bam. And then we're going to punch this into our calculator. 7.5 times 1,000 times 1 divided by 65 is going to give us 120 minutes. So there's our time. And so looking at our sig figs here, oops, looks like they made a mistake. The publisher made a mistake here. This should actually be 2 sig figs. You'll see mistakes pop up sometimes in these slides, unfortunately. And we'll just kind of go through and try and correct them when we find them. This is exact because meters and kilometers are in the same measurement system, and therefore it won't affect our sig figs. And then right here we have 1 minute equals 65 meters. So the minute is exact, but the 65 is 2 sig figs. Usually the ones in these conversion factors are exact, even if it's a measured quantity. And so ultimately we can only know our answer to 2 sig figs because both our measured quantities are only known to 2 sig figs. So please pause the video and complete questions 3 and 4. Once you're done, come back here, please. Welcome back. We're almost done. Let's do our final push and get this section finished. So let's talk about density. In lab number 1, we'll be measuring density of some objects. And so what is density? One way to think about density is how heavy something is, but mathematically it's going to be the mass of a material divided by the volume of a material. And the units vary, but most often what we're going to see is it's going to be grams per cubic centimeter or grams per milliliter for solids and liquids. And that's usually what we're looking at. And these are actually equivalent to each other because 1 milliliter is equal to exactly 1 cubic centimeter. These are in the same measurement system. And so things we tend to think about as light have a low mass, so something like balsa wood or feathers. And things we tend to think about as being heavy have a higher mass for a given volume. And so that'd be maybe things like lead and gold and rock and concrete and those types of things. So we can actually use density as a conversion factor. Hooray, right? I'm sure you're very excited to learn this, but we have a problem right here. An unknown liquid has a density of 1.32 grams per milliliter. So that's an important piece of information. And asks, what is the volume of a 14.7 gram sample? So if we have 14.7 grams, that's going to be our starting value. And then we can, if we know that 1 milliliter equals 1.32 grams, we can make 2 conversion factors. And we're going to pick the one with grams on the bottom, so we can cancel with the grams in our starting value here. And so 14.7 grams times 1 divided by 1.32 is going to give us 11.1 milliliters of liquid. And look at that, there's some more mistakes in these slides. They just pop up here and there sometimes. So our starting value is known to 3 sig figs. This value is known to 3 sig figs. The 1 is exact, as they often are, but the 1.32 is measured, because someone have to measure the density of that liquid. And this should actually read 3 sig figs. So even though they gave it to the right number of sig figs, there's a typo right here. All right, so that is density as a conversion factor. We can also use percent as a conversion factor. A percents are ratios, essentially, where we have a part over a whole. And they give the example here, if a food contains 18% by mass of fat, we can write 2 different conversion factors for that. So that means that we can write that there's 18 grams of fat for every 100 grams of food, or 100 grams of food for every 18 grams of fat. We just have to take the appropriate one to cancel the units we want to get rid of and end up with the units that we want. And so I'd like you to now complete questions 5 through 8 in the activity. And also, now would be a great time to go back and do the sort of bonus extra tough practice problems in the sig figs activity in problem number 6. So thank you and good luck.